Hello dear students, today let us discuss the question number 14 of the chapter on fluid mechanics. Alright, so the question number 14 says that for a vertical semicircular plate submerged in a homogeneous liquid with its diameter d at the free surface, the depth of center of pressure from the free surface is. So we have a semicircular plate whose diameter is just at the free surface of the liquid in which it is submerged. So let us say that this pointer indicates the free surface. So this semicircle is immersed in such a way that its diameter is just touching the free surface. If this is the side view of this semicircular plate submerged in this homogeneous liquid, we can say this is how it looks if viewed from this side. Now, since this plate is submerged vertically in this homogeneous liquid, there must be a point where it must feel all the pressure acting because of this liquid on it. So it's submerged in a liquid which is static. So there is a hydrostatic pressure acting on this plate. And this pressure or the resultant force due to that hydrostatic pressure must have a center somewhere on this plate, right? So let us assume that this is the point where all of the force is acting on this plate immersed in a liquid. All right, so the formula to find the depth of the center of pressure is YC equals Y bar plus ICG upon A times Y bar. Now let us try to understand each and every term in this equation. YC in this equation is the depth of the center of pressure from the free surface along the plane of the plate. Now we need to understand here that suppose if the plate is not vertical and it's inclined, then YC would mean, suppose this is the center of pressure, then YC and this is the free surface, then YC would mean this distance from the free surface, that is the distance of the center of pressure from the free surface along the plane of the plate. Here it's a little simplified because the plate is vertical, but in exams we can encounter a question where the plate is inclined, so we need to make sure that we are treating YC in a way that means the center of pressure is along a plane which is parallel to the plane of the plate. Okay, because we may mistakenly consider that YC is the depth of center of pressure like this, but in reality, for the purpose of using this equation, YC is the depth of the center of pressure along the plane of the plate, and we need not to treat it as a perpendicular distance from the free surface. All right, so now coming to the next term is Y bar. Y bar is the depth of the center of gravity of this plate. All right, so let us say that this is the free surface and a plate is immersed like this. Now this plate would have the center of gravity somewhere on its surface. So the position of the center of gravity on the plate and the free surface, all right, the distance between the position of the center of gravity and the free surface is what this y bar means. Now the next term is the ICG. ICG is the moment of inertia about an axis passing through the center of gravity of the plate. A is the area of the plate and y bar is, like we discussed, the distance of the center of gravity from the free surface. In general case, it refers to the distance along the plane of the plate, but for this question, we can safely assume that it is the perpendicular depth from the free surface. Suppose if center of gravity is somewhere here on this plate, then y bar is the distance from the free surface to the center of gravity of the plate. Now let us try to solve this equation by finding out the terms one by one. So first of all, we need to find out y bar, which is the depth of the center of gravity of this semicircular plate from the free surface. All right, so since the diameter d of the semicircular plate is exactly on the free surface, so y bar is simply the distance of the center of gravity from the base of the semicircular. So the distance of the center of gravity from the base of a semicircle is given by the formula 4 times radius upon 3 pi. All right, since the equation is given in terms of the diameter, so we can rewrite the equation as 4d upon 2 times 3 pi, since radius is half of the diameter. So y bar is 2d upon 3 pi. So we have found out the first part of this equation. Now let us find out the ICG. All right, that is the moment of inertia about an axis passing through the center of gravity of this semicircular plate. All right, so if this is a semicircular plate and let us say that B is an axis passing through the base of the semicircle and at a distance of 2d upon 3 pi, that is this distance, that is the distance of the center of gravity from the base of the semicircle. So let us say that we have an axis passing through the CG of the semicircle. Now we can use the parallel axis theorem here and say that the moment of inertia about any axis, say the axis BB in this case, equals the moment of inertia about an axis passing through the CG plus the area times the square of the distance between these two axes. So we have two axes, the axis BB and the axis CZ, which passes through the CG of the plate. So using the parallel axis theorem, we can say that the moment of inertia about B equals the moment of inertia about an axis passing through CG plus the area times square of the distance between the two axes. All right, so if we need to find the ICG, because that's what we have to use in the equation ultimately, we can rearrange this equation as ICG equals IBB minus A times h square. Now, the moment of inertia of a semicircular plate about an axis which passes through its base equals pi d to the power 4 upon 128, because in case of a circle it's pi d to the power 4 upon 64. So since semicircle is half of a circle, the moment of inertia about an axis passing through the diameter is half of the moment of inertia about an axis passing through the diameter of a circle. So going further, area A is the area of the semicircular plate, which is the pi times d squared upon 8 times h here is 2d. This is h, the distance between the two axes. So h is 2d upon 3 pi squared. All right, so let us simplify this equation. All right, so we can rewrite it as all right, so this is the second part of the equation where we have arrived at the value of the ICG. Now we need to find out A times y bar. Now A is the area of the semicircular plate, which is pi d square upon 8, and then we have y bar, which is 2d upon 3 pi. Since y bar is the distance between the free surface and the CG of the plate. All right, so let us rewrite this as pi d cube upon 12, yeah, just 12. So ay bar is d cubed upon 12. All right, so let us go back to our base equation, or we can first of all try to simplify it as ICG upon ay bar, because we need to put that factor in this equation to find out the center of pressure. So ICG is pi d to the power 4 upon 128 minus d to the power of 4 upon 18 pi. Then this whole entire ICG is divided by this factor of ay bar, which is d cubed upon 12. Right, so this simplifies as pi d upon 128 times 12 minus 12 times d upon 18 pi. All right, so let us simplify this factor. So this is 3 times pi d upon 32 minus 2 times d upon 3 pi. All right, so this is the second part of this equation. Now let us go back to the equation of yc, that is the depth of center of pressure equals the depth of the center of gravity plus ICG upon AY bar. Now YC equals Y bar. We have found it here. So let us put this value 2d upon 3 pi plus, and this is ICG upon AY bar equals 3 pi d upon 32 minus 2d upon 3 pi. So the difference of these two is null plus 3 pi d upon 32. So the depth of the center of pressure in this scenario of a semicircular plate being immersed vertically in a homogeneous liquid in such a way that its diameter is just at the free surface is 3 pi d upon 32. All right, so to visualize it a little better, let us take a look at the side view of this immersed plate. This is the free surface. All right, let us say that this is the CG and this is the CP, or the depth of the center of pressure. So Y bar is 2 times diameter upon 3 pi, right, this, and the depth of center of pressure, that is YC, or the depth of center of pressure YC is 3 times pi d upon 32. All right, so for the purpose of understanding, let me quickly find out the value of 2 upon 3 pi, this factor, and this factor 3 pi upon 32. So 2 upon 3 pi is 0.21 d, and 3 pi upon 32 is 0.29 d. All right, so we need to understand the depth of center of pressure is a little more than the depth of the CG. All right, so this was our plate, and we can safely assume that the distribution of the hydrostatic pressure is something like this. All right. So the force on this semicircular plate is concentrated a little below the CG. All right. So if this is the CG of the plate and this is the CP or the center of pressure of the plate, then this depth is 0.290 and this depth is 0.21 times of the diameter. Now let us go back to the options. So the first option is what we need to take in the exams, because we have found out that the depth of center of pressure is 3 times pi d upon 32. So the answer is A. Thank you for watching.